Hello everyone, welcome to the combinational and sequential design practical series. In today's session we'll study about XS3 addition and subtraction. We'll construct XS3 adder and subtractor. So how does it work? First we must know the rules for doing this addition. So suppose if we are adding two XS3 numbers and if the result is a sum which is less than 9. So XS3 of 9 is 1100. So in case if we are adding two numbers and the sum is less than 1100, then we need to subtract 3 from the given result to get the final result, because when we are adding we get actually XS6, so we need to subtract it so as to get the XS3. Now let us see one example. So we have number 1 plus 3. So first we find the XS3 of 1. So XS3 of 1 is 0100 and XS3 of 3 is 0110. Now we are adding this, so we get 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 0, carry 1, and we get this number. Now we are getting 1010, okay, but this is actually 7 according to the XS3 notation, so actually XS3 coding. So this is not the correct answer, we must get 4. Okay, so the correct answer is 4, which is 0111. Okay, 0111. So this is the correct answer we must get. So how to get the proper result? To get the proper result, we subtract 0011 from the given result. So from the previous example we have this data, so we have this result, so we subtract 3 from this, so which is 0011, and when we subtract this 1010 minus 0111, we get the result as 0111, which is 4 in XS3. So we get the correct answer. So now suppose if we have if we add two XS3 numbers and it gives a sum which is greater than 9, that is 1100, then in that case we need to add 3 0011 to all the digits. In case if we are getting a carry, of course, then we need to add the 0011 to that carry digit also to the final, to get the final result. For example, if we are adding 6 plus 5, so 6 in XS3 is 1001 and 5 in XS3 is 1000. If we add these numbers, we get this 1 plus 0 is 0, 0, and 1 plus 1, and we get 0 and a carry 1. So this carries, of course, we get the carry here. Now this is not the proper result, this is an incorrect result. The correct result is 0100 0100. So the result would be of this type, but we are getting an incorrect result. Now let us begin with the previous example. So we need to add 3, that is 0011 to both the digits to get the proper result. So from the previous example we have 6 plus 5, so 6 is 1001 in XS3 and 5 is 1000. So when we add we get this. So now we add 3 zeros to the left digit 0, it doesn't change the number, it will, the number will remain as it is. Now to get the proper result we add 3. Okay, so here we add 3 to the rightmost digit and the left digit, and when we add it, what we get is 0100 and again 0100. Now 0100 is 1 in XS3 and this also is 1 in XS3. So the final result is 1 1. Of course that is expected, 6 plus 5 is 11. So we are getting the proper result now. So this is the what result we are getting. There we have this particular circuit, we have, okay, two adders. So in the upper this part, this will add the given digits, okay, and in case if the sum is less than 9, then this logic will take care of subtracting 3, and if it is more than 9, then this will take care of adding the 3. So we get the final result here, and this is the rightmost digit and this is the leftmost digit. So this is the logic we have in case we want to design this XS3 adder. Now let us execute this using the SimulIDE. We'll do this afterwards. Let us I'll just explain the second part, this XS3 subtractor. So what principle we use in XS3 subtraction is that we used 2's complement subtraction as we did in the previous video of BCD subtraction. So everything remains the same, only the thing is we are converting the B as a 2's complement and we get the output result similar way. Now let us execute this using SimulIDE. So now we are into the SimulIDE. I will construct the circuit. So if you want to get a detail, I have given the detail in the previous video. I will just go fast in this particular case, so as to save the time. So now we have constructed the circuit. Now let us apply some inputs. So in the presentation I have shown 3 plus 1, so we must get 4. So but in this case we need to enter the data in excess 3. So I will apply 3 on this B. This is the B part, so I'll apply 3 B on this and 1 on A part. So 3 in excess 3 is 0 1 1 0. So just turn on the power supply. I'm not starting the simulation, so I want to enter 0 1 1 0. So this is 0, then I just click here 1. So green means 1, 0 1 1 0. So this is 3 0 1 1 0. Now this 4, they are for 1. So 1 in excess 3 is 0 1 0 0. Okay, so these are the inputs. Now I turn on the simulation. Now what expect output is 0. I will get 0 here, and all this will glow. So 0 1 1 1 should come. Okay, so that is what we are getting. So 0 1 1 1. So this is actually 4 in excess 3. So this is the answer we are getting. Now I'll just stop the simulation. Okay, and then apply the second input where we added, if you remember, we added for 6 with 5. Now 6, let us adjust 6 first. So 6 is 1 0 0 1 in excess 3. So 1 0 0 1, then plus 5. So 1 0 0 0. So this is 6 plus 5. So we must get 11, but 11 is 0 3. So now we are getting carry. So all the digits, this LEDs, this probe will represent the leftmost digit and the right digit. So just turn it on. So we are getting this 0 1 0 0, and of course this is the answer. We must get 0 1 0 0 and 0 1 0 0, both the digits. So this is how we perform the excess 3 addition. Now excess 3 multiplication, subtraction can also be performed in the same way. Only the difference is that we are not applying B directly but through an XOR gate, and also carry will become 1, so that we are doing the subtraction using 2's complement method. So that I leave it to you. You can perform it. Okay, so that's all for this particular session. Thanks for watching.